Okay, this is part 2 of controlling 15-segment displays from 8-segment controllers. I wanted to talk a little bit today about 7219 controllers, because I really haven't covered that much, and it is fairly important to what we're doing with these 15-segment displays. What you see here is basically the same circuit that you saw in the last video. Because it had been so long since I looked at this thing last, I decided to build it out a little bit more, just to make sure that I really understood how the circuit expands as I add more display units. No real surprises here, but it was becoming very apparent how many pins I was going to be burning when I scaled this up to full size. I'm going to have 48 digits in my application in 3 rows of 16. Each 8 digits requires a pair of 7219 controllers. So I was going to be running, well, originally I was thinking 3 chains of controllers, and each chain was going to burn through 3 pins on the Arduino. It turns out that the amount of time that it takes to shift out data to 8 characters on 2 controllers in one chain is about 10 milliseconds. Unfortunately, shifting out to 4 controllers, so shifting out to 16 digits, takes 4 times that long. It's not too terribly surprising. Because of the way that these things operate, there's an n-squared relationship in the time that it takes to push out data, and I can't afford to pay that cost. I want this thing to be really quick. And so I'm going to go with 6 separate chains of controllers. Now, if I'm running 6 controller chains, that's going to burn through, well, times 3 pins, that's 18 pins on my Arduino. And I really can't afford that either, because I have several buttons on my application, and I have several, and I have a GPS module that's going to be connected into it. So I needed to make sure that I needed to find some way to cut down on the pin load. This is just a simple demonstration circuit of the solution that I came up with. I'm not sure whether solution is quite the right term for it, but let's go over it really quick. Excuse me. So, as I hope you're aware by this point, 7219, the LED controller, operates on a 3-pin communications system. There's DIN, which is short for data in, there's clock, and there's load. And this thing stores up 16 bits of data in its register, unused until you command it to swap that storage into actual use. I'll get to that in a second. So if I want to load a bit into this thing, let's say I want to load a 1, I stick a 1 on the data in pin. I can't remember if that's high or low, it doesn't matter. But I then raise the clock pin, and that takes whatever is being represented on this pin and sticks it into register memory. There's also a D out pin here. I'll get to why in just a second. When clock drops, anything that got shifted out of the end of the 16-bit storage comes out here. So if there was a 0 here, it gets shifted out to here. And the reason for that is if I have my second 7219 in the controller chain here, it needs a DIN, and it's going to be coming from here. Alright, so we're moving all these bits through these registers, 1, 1, 0, and at some point we need to tell this thing that those 16 bits represent an actual command, and we tell it that by raising the signal on load. Whatever is stored here gets interpreted and sent into the controller's internal hardware. Let's say that it's a command to set the bits of a row. It interprets that data and changes what it is displaying as a row. If it's a command to change a column or the brightness or whatever, at the moment that load goes high, these bits get interpreted as a command. Well, you can imagine what happens if I have 8 of these chained up. If I want to change 8 bits on the leftmost controller, I have to shift those 8 bits through every single one of these controllers to get it stashed here, or at least that's how the LED controller library on the Arduino works. This is something I will probably rewrite at some point so that I can just feed it the set of commands for all 8 controllers and flip the load pin, and all of them will execute their commands all at the same time. The current implementation is terribly wasteful. But anyway, I did notice that I could have several chains. I could have several chains of 7219s, each sharing the same DN pin. So I do manage to share one of the 3 pins, which means that with my 6 chains of controllers, times 2 pins per controller plus the 1 data in pin, I get it down to 13 pins. I can cut that nearly in half if I can deal with the timing issue and set it up so that my row of 16 digits is controlled by 1 chain of controllers. I'm not sure I want to go to the software cost of rewriting the LED controller library yet. It may be unavoidable. But anyway, so part of what this circuit was here to do, this little guy, was to demonstrate that in fact I can share that clock pin. Unfortunately, I got a little greedy, and I thought that it would be possible to also share the load pin. Because you can imagine what would happen if I had, this, 001, blah, 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 101, sitting here in this thing's registers, and load goes high. It interprets that as a command, and then I was hoping that that same 001, blah, 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 101, would still be in the shift register, and that if load went high again, it would simply get interpreted as a command again. And unfortunately, that's not the case. When it loads a command, it blanks out the shift register. The reason this is important is you can imagine if this thing is sitting here with something in a shift register, it's already interpreted as a command, and then I start feeding data to a different chain. Okay, I'm flopping D in, but if I'm not moving the clock pin on this first chain, nothing's being shifted around, right? The shift register should remain the same. Only the second chain would be actually shifting data to the left. I was hoping to take advantage of this in that I could use the same controller library, use the LED controller library, but only have the clock pin unique to each chain and have DN and load shared. That would be great, because then it'd be 6 times 1 plus 1 equals 7 pins, which I can totally live with. Unfortunately, when I did that, I got garbage on my circuit, and in fact what I got was, instead of the bits of random data that you see there now, what I was getting was a completely lit up panel on both LED controllers. So anyway, that's a basic rundown of my condition with the 7219s. I'm probably going to make another video very shortly about what my actual application is. It just turned out to be too long a conversation to be doing both of these in one video. So anyway, stay tuned. It won't be long before we have a little bit more of an in-depth conversation. If you have any questions, go ahead and post them. Take care.